Hi, everyone. Welcome to part two of this LIUniverse conversation with Dr. Katie Mack. If you haven't seen part one yet, it should be linked in the show notes for you to watch. So let's jump right back in. So let's get another question. Alan, what do we have?
Yeah, so this question comes from David, who is asking, he was wondering if physicists have looked into the idea that the empty space in an atom is actually filled with dark matter, and
Hmm.
what experiments could we do to prove or disprove that?
Where the heck did that idea came from? I mean,
yeah,
that's
yeah,
interesting.
he has a little bit that he says they were looking at a map app, and then felt like they were flying over the water, and then it sort of conversation morphed into it. I guess imagine something about like water fills the space between land.
Oh, okay. So dark matter fills a space inside the atom. Okay, all right, that's cool. Katie, what do
Yeah,
you think?
so it's an interesting question. What we see as dark matter, the reason that we think dark matter is there is because we see a lot of extra mass in
Mhm.
places where there's already some matter. There's light, producing matter like galaxies and stars, but we see evidence for there being extra matter that we can't see. So, like for
Mhm.
example, in the way that galaxies rotate, the stars seem to be whizzing around the center of the galaxy faster than they should be. There must be extra matter holding them in so they don't fly off into space.
Mhm.
In clusters of galaxies, you see the galaxies moving around too quickly. There seems to be extra matter that's holding this stuff in.
Yeah, with all
Um,
its gravity. Yeah.
yeah, and you see this in a lot of different contexts, but you also see it in places where the regular matter is pretty sparse. So, for
Hmm.
example, in some of those some in galaxies, the regular matter in the galaxy is pretty concentrated in, sometimes it's in a disk, sometimes it's in a sort of oval sort of shape,
Mhm.
but it's
Yeah.
in the sort of middle parts of the galaxy. But if you measure how much gravity there is in that region, and you can do that by looking at how space itself bends, which you can tell by how light moves around. It's a very
I love
cool
that stuff.
method,
Mm.
Yeah.
gravitational lensing. You actually see that the extra gravity extends far beyond where just the light stops. So
Hmm.
it's not just
Aha.
that the atoms are heavier. Um, if it were just that the
Mhm.
atoms were heavier, then we would see different patterns. We would see that all of the extra matter was completely coincident with where the atoms are. There seems to be something that is separate from atoms that collects in different ways, that has different behavior, that is not just where the atoms are. And we've even seen systems where there's some separation between where most of the visible matter is and where most of the dark matter is. So you can tell
Mm.
that it's not just the regular atoms being more massive. So we know that dark matter doesn't just exist where atoms are. Um,
Wow. So they
Yeah.
have to be completely different particles?
yeah, so that's what we think. The sort of the best guess that we have is that dark matter is some new kind of particle that is not one of the particles of the standard model of particle physics. So it's not any of the particles that we've detected in laboratories or that we've seen, existing in in particle detectors, or we've seen as part of atoms. There seems to be some other kind of particle that's not part of that system that has
Wow.
properties where it has some kind of mass, but it doesn't interact with light. It doesn't interact with electromagnetism. That's why we can't see it. That's also why it sort of passes through regular matter without interacting with it,
Yeah.
because it doesn't have, electrostatic repulsion. It doesn't bounce off stuff the
Yeah.
way that regular matter would. So it
Wow.
does seem to be something very different. And it doesn't seem to have a particularly special relationship with atoms at all. It kind of doesn't care about them.
Yeah.
so,
That's fair.
so
So it's
Wow.
not that
um,
it's filling it in because all
yeah,
the things you said. Yeah.
yeah. So in terms of the
Big
empty
words.
space within atoms, like there's empty space, but there's also a lot of like electrical field stuff, right? So
Yeah.
there's
Uh-huh.
energy,
Mhm.
and there's some, like there's an electron kind of going around the nucleus of the atom, and you can't really say exactly where that electron is, so you can't really say
Hmm.
it's not in
Yeah.
any particular place. So even talking about atoms having empty space is a little bit tricky, um,
Yeah.
but
It's the
dark matter,
joy of uncertainty. Yeah.
yeah, but dark matter is seems to be some different kind of particle, and it really just acts like a particle. So, a
Wow.
lot of people ask if it could be, maybe gravity works differently or something like that, but it really acts like a particle in the sense that, like, if we did like a computer simulation of, regular matter, where the regular matter can light up and it can bounce off of other matter and stuff like that, um,
Hmm.
but the dark matter can't. The dark matter just has gravity and it passes through itself, it passes through other matter, and you just populate your simulation with regular matter particles and dark matter particles, you get something that looks exactly like what we see. So whatever it
Wow.
is, it
Okay.
acts just like it's a kind of particle that has gravity, doesn't do electromagnetism. And in every
Wow.
context we've observed, it really acts like that. So so
Yeah.
you can try and tweak, gravitational laws to try to mimic some of these, and in some contexts it works great. You can get amazing, amazing agreement with, like, changing the law of gravity to change how galaxies rotate. But then when you try and add up all of the evidence from, like, gravitational lensing, from the way that galaxies
Yeah.
grew up in the early universe, from the large
Hmm.
scale distribution of matter on galaxy cluster scales, all of that, it really works much better if dark matter is just some new particle that has mass but not electromagnetism, and that's it.
Fantastic.
Cool.
That's really good to know. I mean, when I was in graduate school, like a gazillion years ago, okay, I was taught that the amount of dark matter in the universe would dictate the ultimate fate of the universe. But now
Yeah.
it seems like it's utterly irrelevant. Isn't that,
Well,
is that right? I mean,
no, it's just that now dark energy is what's going to dictate our fate.
Ah,
Right? It's
yeah.
just more
dark
of it.
energy
Picked
is
another dark
totally.
thing. Okay.
Yeah, well, so the reason that we thought it was dark matter before was because we thought that, the early universe had the Big Bang, the expansion started, and that kicked off this expansion, and then all of the matter in the universe was pulling together, and it was slowing down the expansion of the universe. And if there was enough dark matter, then that expansion would stop because there would be so much gravity, it would pull everything back together, and then everything would collapse in the Big Crunch.
Uh-huh.
That was
Uh-huh.
the idea that we had at the time. But then we figured out that there's really not enough matter to slow everything down that much to stop everything. And when we measured how quickly the universe was slowing, we found it wasn't. It was actually speeding up. And so
Yeah.
Oh.
then we had to hypothesize something new, which we call dark energy, which
Mhm.
makes the universe
Mhm.
expand faster and faster. And so now, the evolution of the universe is almost entirely governed by what the dark energy is doing, and we don't
Wow.
understand
Yeah.
that at all. Like, that's a whole other topic, but
Yeah. When
all
we're
we
talking
all
with
we can say about that is that it's making the universe expand faster.
Yeah, we
Wow.
had a previous guest on LIUniverse, Yun Wang, who was talking about dark energy and like
Mhm.
how the different natures of dark energy could dictate
Yeah.
the
Right.
universe
She's part of
accelerates
the
forever, or
Euclid
does other
project.
things like
Yeah.
that.
The
Right.
Euclid folks who are
Yeah.
taking vast maps of
Yeah.
zillions and zillions of galaxies.
Yeah, it
Yeah.
So,
was very
Yeah.
exciting.
Yeah, there's super exciting stuff with that, and there was some recent. There's a recent result from the DESI survey, the Dark Energy Spectroscopic
mm,
Instrument, where they found something that looked like it could be this weird kind of dark energy that changes behavior in the future. Then that's a whole other
ooh,
story, but it's
wow.
we don't know. We really don't know what dark energy is doing. We have our
Oh, that's amazing.
hypothesis that it's this fairly simple kind of addition to the universe called the cosmological constant, but it could be something that's not constant, that's changing in the future in some really interesting way,
Yeah,
and that could
Wow.
totally change how the future of the universe evolves.
it's pretty
And,
awesome.
and you talk all about that in your book, right, Katie?
Yeah, I mean,
Yes.
we talk about different
Yes.
possibilities for dark
Yes.
energy. Some where dark energy, becomes more powerful. Some where dark energy kind of changes and goes backward in
Yeah.
some
Yeah.
ways.
Yeah.
Um,
So,
this
so,
new observation is a different idea than what I talk about in my book, but you can kind of
uh-huh.
extrapolate.
Okay. The book. Show us the book.
Oh, yes,
Show
yes.
us the book.
Here's my book.
For those of you who are on YouTube, you can see this. This is The End of Everything, Astrophysically Speaking,
Love the
by
New York
Dr. Katie
Times
Mack.
best-selling thing there.
There you go. Yeah, it's got that little
It's
tag
a
right there.
New York Times 100 notable books of 2020. That's what the little.
Woohoo!
That's awesome.
I
That
It's a
is
love that.
awesome.
notable book. Yeah,
It's a notable book. Well,
yeah.
definitely for sure.
Well, certainly notable for us. Also notable is the next question that we're going to have. Ha! Give us a question.
All right, we got another question here. This question is coming from Eileen Balderas, who is asking about something called the gravitational memory effect. Eileen says the gravitational memory effect talks about how space remembers certain things. Gravitational wave signals could make the universe remember what happens to it. And their question is, how can scientists? The question is, how can scientists say the universe is able to remember things?
Yeah, so
Ooh.
this is a really fascinating phenomenon that I only learned about like maybe 5 years ago. But when we started to detect gravitational waves, now gravitational waves are disturbances in space-time caused by massive things moving around in accelerated ways. So the standard thing is two black holes spiral in together and collide, and when that
Hmm.
happens, they create ripples that kind of move out through space. And those ripples, what they're doing is they're kind of stretching and squeezing space kind of back and forth. And we detect that with instruments that are measuring sort of how space is distorted when those waves pass through. And the gravitational memory effect is this idea that when a gravitational wave passes through, like when one of those events happens and we measure these gravitational waves, it creates a kind of permanent distortion in space
Hmm.
that doesn't go away.
Wow.
Like there's a stretching and squeezing, and at some level it gets a little stretched and it doesn't come back. And that's what gravitational memory means, is that there can be a permanent sort of scar, a sort of permanent
Wow.
Oh,
distortion
wow.
of
Well,
space-time every
it's
time
kind of
one of
like
these
when
events
you have
happen.
like a permanent magnet and you pass a needle past it a whole bunch of times in the same direction, you can turn the needle into a permanent magnet. It's like
Yeah, I guess so.
it's just staying there forever.
Yeah, I mean, I think of it more as like if you kind of stretch out some fabric and you can't quite get it to come
Oh,
back,
it
right?
never comes back again. Yeah,
Yeah,
you
it's
overstretch a
never
rubber band or something.
yeah, it's
Hmm.
never
Hmm.
quite back the way it started. That's kind of
I
how I
see.
think of it in terms of
Space time can do that.
yeah,
Wow.
so there can be this permanent distortion, and it's tiny. It's not sort of measurable, and as far as I'm aware, it's a very small
Hmm.
effect. But according to the theory, it is a real effect that happens when gravitational waves
Wow.
distort the space. They distort it so much that it gets a little bit out of whack every time. And maybe I
Wow.
think this is something that there are ways to look for evidence of this, but it's part of the theory, and it's just because space time is this malleable thing that can be distorted and disrupted, and
Okay.
apparently it
So
can happen
so
permanently.
yeah. So the universe has memory the way that like memory foam has memory, not like
Sure,
the
yeah,
way elephants have memory.
yeah,
Okay.
yeah.
I can understand that. That makes total sense. Okay, that's cool. Wow.
So,
Great question. That's amazing.
Yeah.
Um, wow, Katie, we there's still so much more I want to talk with you about. We're running low on time, but I gotta get to them as quickly as possible.
Okay.
Um, Flying. You
Yes.
fly. That's
Yes.
amazing. Tell me about the flying thing.
Okay, yeah. Yeah, so in late 2020, just after my
Mhm.
book came out, I was sitting around in Massachusetts because everything was remote, and I was living in Massachusetts for a while. And
Mhm.
I was doing all of my meetings, and all of my work were like this, talking to a little screen.
Yeah.
Um,
Yeah.
and um, I really needed to get out of the house, and and I and I noticed that there was a flight school really nearby, and they had a big sign that said "Learn to fly here," and I thought that sounds like a great idea. That'll get me out of the house.
Wow.
And it was a
Awesome.
fairly sort of COVID safe sort of thing, because you wear a mask in the plane with your instructor, and there's only one other person, and wipe down all the controls and everything. That's what we were doing at the time, and
Wow.
yeah, so I learned how to fly airplanes. So
that's pretty
That's
awesome.
that was kind
marvelous.
of my sort of lockdown hobby, was learning how to fly airplanes.
Well,
Um, and
that's great. Once you get up there, right? The next stop is space, right?
that's
How
that
much
yeah,
further do you have
sure.
to go?
I mean, I've
And
sent in my application. I'm waiting to hear, but
yeah. Oh,
Fair.
that's
we'll see.
fantastic. Yeah, the space thing. Do you want what would you like to do? Go like where no one has gone before or sort of to the moon and back? I mean, what do you
Oh
want to do?
man, I don't mind. Get me up there. I'm happy to do anything that's connected to human space flight. I think that would be
Oh,
amazing. So,
That's wonderful.
wonderful.
but yeah,
Well,
I would love to go to space. very few people do, and there are lots of
Hmm.
reasons that
Right.
those things don't work out. But even if that never happens, I do really enjoy flying. I'm just it's been
Oh yeah.
That's
such an
pretty
amazing
awesome.
thing to be able to do, and I've been very lucky to be able to do that. Essentially, it's something that takes a lot of time and money. And what happened was, my book came out, so I got some money, and then all my hobbies evaporated with the pandemic, and it was like, well, now I have ton of money, so that
Oh,
was
I
my
love that. That's
idea.
fantastic. So do you still have a plane that you fly in Massachusetts, or is it?
No, I'm
Uh,
not in. No, I when I was in Massachusetts, I was flying the flight school planes,
mm,
and now I'm doing a bunch of different kinds of training at the moment. So there are a bunch of
mhm.
different planes that I fly, but I also
Wow.
have I have a share in an airplane. So with four other people, I own part
Oh
of
yeah,
an airplane through a kind of a
Oh,
weird thing.
super
So
I've
cool.
heard that's
there's
a
a
thing
plane
you
that
do. Yeah.
I can use regularly. So yeah, yeah.
Well, um, I don't imagine, but maybe there is any
Mm.
connection between, the flying and how you connect it to your work in theoretical cosmology or anything?
I mean, I think the thing about it is that I think the reason that I like it so much. I mean, there are a few reasons I like flying, but one of the reasons I like it is that it's like this very challenging technical skill, right? And
Mm,
it's just
Mm.
kind of I enjoy like that's just something I'm really into, and that's very
that's
related to the
awesome.
kind of work that I do. But really, I find that it's a nice way to completely decouple from work because when I'm in the plane, I cannot be thinking about anything other than flying. I will die, right? Like,
Right.
so
Great
it's
point.
really
Fair. Yeah.
effective
Uh-huh.
as a break
Hmm. Hmm.
sort of
You,
work related thoughts.
yeah. You are not checking your emails while you're
No,
up there.
no, I'm not.
Yeah. That.
Now, is it a big plane, a small plane,
No, no,
a
no,
fast
just
plane?
single engine. Yeah, yeah. So
Cool.
the plane that I own a share in is called a Mooney. It's a single engine airplane. It's reasonably fast for a single engine airplane, but it's not
Hmm.
it's not a jet or something like that.
Oh,
All right.
well, that would be
Cool.
so cool. Uh, Speaking of where no one has gone before, Star Wars or Star Trek?
I really enjoy Star Trek. I always have. I like that
Woohoo!
kind of view of the future.
Hmm.
I respect Star Wars as well, but I kind
Uh-huh.
of grew up with Star Trek. Yeah.
Yeah, yeah, yeah. That makes total sense. Okay, so we chalk up another vote on the tally board, Alan, for Star Trek.
I don't know how many people we've asked that. We have definitely a few.
Oh, a whole bunch. Yeah, we gotta get that going there.
Yep.
All right. Well, last thing I
Mhm.
have to ask you because you are at the Perimeter Institute.
Yes.
What is a Perimeter Institute? I
So
mean, I know
yeah.
what a perimeter is. It's that
Yes.
edge around a
Yeah.
shape or something, right? You
Yeah.
can measure it in inches or whatever. But
Yeah.
I know most of our audience is not in Canada, and we haven't
Okay.
heard of this prestigious institution. So
Yeah.
tell us what this is, please.
So the Perimeter Institute is it's an independent physics research institute. So it's the Perimeter Institute for Theoretical Physics, and
Aha.
I think that the word perimeter there is kind of like thinking about kind of the edges of our knowledge, but also the founder of the institute, Mike Lazaridis, who was the person who kind of put in the initial funding for the institute. He
Uh-huh.
he ran a company called RIM, Research in Motion, and I
Ah,
think that rim in
blackberries.
perimeter, I
Oh,
think it fits in there.
cute.
I haven't actually
Yeah.
confirmed that with anyone, that's my hypothesis.
Oh,
Um,
that's
All
neat.
right.
but
So
yeah,
RIM was the company that founded
yeah,
BlackBerry, or
yeah,
was the
yeah,
BlackBerry thing,
exactly.
which was so
Yeah, so
important. And
I think what happened was he made a lot of money with that, and then he wanted, physics was a passion project for him, so he founded
oh,
this institute. And the way it
oh, I
works
love
is
that.
that it's an independent research institute. We get some of our money from the endowment, some of it or some of it from like, you know, um, charitable donations, some from the federal government, some from the provincial government, and
Mhm.
the goal of the institute is to really stretch the boundaries of our understanding of physics. And so we have a bunch of different areas of physics that we work on: cosmology, particle
Mm.
physics, quantum information, like all kinds of areas of theoretical
Wow.
physics. We have
That's awesome.
connections with a couple of different industry places where some of those ideas are applied, but mainly it's about pure research. And we also have connections with universities so that we can I have graduate students, I have research grants,
Oh,
so
that's
I act
great.
in a lot of ways like a professor, except that I don't teach classes. I supervise
Ah,
students and I do research. And then I also have a position there where I spend part of my time on public engagement, so stuff like this,
Awesome.
talking to
Oh, that's
people, writing books,
fantastic.
that kind of thing.
Okay, so from your point of view, then,
Mhm.
what advice would you give me and your other colleagues who are still at universities and so
Mhm.
forth? Do you have some sense of like how we can do our jobs better, especially your areas of expertise, theoretical cosmology, and this outreach stuff that you said that you're doing? Tell me
Um,
what I should be doing better.
oh gosh, I don't know. I mean, I think that I think that whatever your job is in academia or I mean, I consider myself still basically in academia because I'm still part of
Hmm.
that system. But even though I'm at
For
an
sure.
independent institute,
Yeah.
we all have so many things that we're trying to do all at once. Like it's
Yeah.
research, supervising, teaching in most cases, public engagement. I think that whatever kind of balance you can find where you are doing what is important to you and what is fits into your career. I think that's I think that we're doing our best, and we should we should do that. Like prioritize the things that are really important where you think you can make a difference. I think is the best I can say.
Awesome.
Well, it's wonderful. There is still so much to talk about. We just don't have any more time. But
Yeah,
Katie, I hope we get the chance to do this again sometime
yeah,
soon. Thank you so much. If there is a way we can keep in touch, knowing what you're doing, projects that you're doing right now, tell us, how can we do
yeah.
that?
Yeah, so I have a website,
Mhm.
astrokatie.com, and on that website you can sign up for my newsletter. So once
Okay.
every couple of months, I send out a newsletter with links to things I've written, talks I've given, interesting little thoughts about stuff. So I write little essays for that newsletter about things that have come up in the news about astrophysics or whatever stuff I'm thinking about related to physics. So you can sign up for that.
Okay.
The newsletter is called Watch This Space Time. I'm also
Ooh,
on
clever.
social media.
Uh-huh.
I'm not so much on Twitter these days because it's kind of gone bad, but I'm Astro Katie
Yeah.
on that one. But then I'm also on
Hmm.
a newer social network called Blue Sky, where my
Uh-huh.
handle there is astrokatie.com because you can use your website for that. So I'm on
Awesome.
there, and I'm on Instagram at AstroKatieMack. But the
Okay.
Instagram stuff, a lot of it is flying, so it's kind of a mix between physics and like videos from airplanes. So if you're into that, then, then check me out
Awesome.
on Instagram. And
Very
Fantastic.
cool.
I've got accounts in a bunch of other places, but those are the main ones that I use.
Awesome.
Marvelous. Oh, okay. Hold up that book again so we can see what it looks like.
Yes. Sorry.
Please.
So,
Thank you.
one other thing I
Uh-huh.
should plug actually is
Yeah.
I've been working with Perimeter to make some video series about physics. So last year we
Oh,
did one
great.
called Quantum 101, and it was
Uh-huh.
sort of short videos about the basics of quantum physics. This year we're
Oh,
doing
awesome.
Cosmology 101, and it's the same kind of format, like five minute ish videos about basics of cosmology. So those are on the
Excellent.
Perimeter YouTube channel. So check those out.
Okay.
And then I'm also on a podcast with John Green called
Yeah, I've seen that
Crash
one.
Course Pod
Really? The
Universe.
immortal John Green?
Yeah,
The
yeah.
the
So
the
we have this limited series podcast that's I think 5 episodes are out now, but we're going through the whole history of the universe. So that's called
fantastic.
Crash Course Pods the Universe, and it's on the Complexly system.
Yeah, I
But
love
anyway, you
complexity.
can
They
find
do
that.
good
Yeah,
stuff.
yeah,
Crash. We don't get any money from Complexly, by the way, or
Yeah.
from John Green or any of the
yeah,
Crash Course anything. We just like them. So
yeah.
just let
They're great. Yeah.
everybody in the audience, just so you know that. But we can find you at Crash Course Pods History of
And
the Universe?
it's called The Universe. Is the
The
pod.
Universe.
Yeah,
Oh, all right. Now I know what I'm going to listen to the next time I take my jog.
great.
Oh, wow. Well, Katie, thank you so much. Dr. Katie Mack, thank you for being on the Universe. Thank you, thank you, thank you, thank you.
Thank you. This was a great conversation. I really enjoyed it.
Thank you. Alan Liu, our co host, as always, thank you so much.
Yeah, always glad to be here.
And all of you in the audience, thank you for being with us today. If you like what you see and hear, please support us on Patreon. And as always, thank you for being a part of the universe.